Welcome to True Projects. In this video, we are going to explain about the project, which is drug overdose detection using machine learning. First, we will know what is the project about. Drugs are the substances that alter the functioning of the body when consumed. Drug overdose occurs when an individual takes an excessive amount of drug, leading to harmful or potential fatal consequences. This project focus is to develop a system for early detection and prevention of drug overdoses. The focus is on leveraging machine learning techniques to analyze patterns in the data to predict and identify potential overdose situations. Traditional methods of overdose detection often rely on manual monitoring or self reporting by patients. These methods suffer from limitations such as human error, subjective interpretation, and the inability to provide real time alerts. The proposed system leverages machine learning techniques to analyze large data sets of drug related deaths, including information such as demographics, medical history. By automating the analysis process, the system can quickly identify risk factors and the patterns associated with overdose events. Machine learning plays a crucial role in drug overdose detection by enabling the analysis of vast amount of heterogeneous data. ML algorithms can detect complex patterns and anomalies in the data that may not be apparent to human observers. Additionally, ML models can continuously learn and improve their predictive capabilities over time, enhancing the effectiveness of overdose prevention efforts. The aim of the project is to develop a machine learning based system for drug overdose detection. The goal is to analyze various factors associated with drug related deaths to predict likelihood of an overdose event. The project utilizes a range of machine learning algorithms including random forest, gradient boosting, XGBoost, K nearest neighbor, voting classifier, ADA boost, bagging classifier, support vector machine, decision tree, and logistic regression. These algorithms are chosen for their ability to handle classification tasks and their effectiveness in dealing with complex data set. The system aims to predict two classes, which is safe and the chance of drug overdose. By classifying individuals into these categories, the system helps in identifying those at risk of overdose, enabling timely intervention and support. The project evaluates the performance of the models using various metrics, including accuracy, precision, recall, and F1 score. These metrics provide insights into the model's overall effectiveness in correctly classifying instances and their ability to balance between true positives and true negatives, false positives. The project aims to benefit stakeholders such as healthcare professionals, law enforcement agencies, policymakers, and individuals at risk of drug overdose. By providing early detection and intervention capabilities, healthcare professionals can address overdose promptly. Law enforcement and policymakers can implement targeted preventive measures based on insights generated. Individuals at risk, along with their families, can receive proactive support, ultimately contributing to public health and safety through machine learning driven overdose prevention. To implement this project, we need software and hardware requirements. So, coming to the software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to the hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. So coming to the first step, which is importing the packages. In this step, necessary Python libraries and packages such as pandas for data manipulation, numpy for numerical operation, matplotlib and seaborn for data visualization, scikit-learn for machine learning algorithms, flask for web framework, and SQLite for database management are imported. The next step is exploring the dataset. In this step, the drug set dataset is loaded into Python environment to understand its structure, content, and features. This involves examining the data types, checking for missing values, and gaining insights into the distribution of variables. The next step is data visualization. In this step, visualizations such as histograms, bar plots, and scatter plots are created using libraries like matplotlib and seaborn to explore relationship between variables, identify patterns, and gain insights into the data. Feature selection. In this step, based on insights gained from the data exploration and visualization, relevant features that are likely to have significant impact on predicting drug overdose events are selected. Feature selection helps improve model performance and reduce overfitting. The next step is data cleaning. In this step, Missing values in the dataset are handled by either inputting them with appropriate values or removing rows or columns containing null values. This ensures data quality and integrity for subsequent analysis. The next step is splitting the data into train and test sets. In this step, the clean dataset is split into training set and a testing subsets. The training set is used to train the machine learning model, while the testing set is used to evaluate its performance on unseen data. The next step is building the model. In this step, machine learning algorithms are built and initiated. The next step is training the model. In this step, the training data is fed into the machine learning model and the model learns to map input features to the target variable. The next step is Flask framework with SQLite for sign up and sign in. In this step, a web application is implemented using the Flask framework, integrating SQLite for user authentication functionalities such as sign up and sign in. This allows users to create accounts and log in securely to access the prediction service. Coming to the next step, which is user gives input as feature values. In this step, users provide input data representing the values of selected features related to drug overdose risk factors through a web interface. Given input is pre-processed for prediction. In this step, the input data provided by the user is pre-processed to ensure it matches the format expected by the trained machine learning model. This involves scaling, encoding categorical variables, or any other pre-processing steps. Trained model is used for prediction. In this step, the pre-processed input data is fed into the trained machine learning model, and the model predicts the likelihood of a drug overdose even based on provided feature values. The last step is final outcome is displayed through frontend. In this step, the prediction outcome indicating whether the input corresponds to a safe or potential drug overdose scenario is displayed to the user through the front-end interface of the web application, providing actionable insights and recommendations. Algorithms which are used for drug overdose detection are random forest. Random forest is an ensemble learning method that constructs a multitude of decision trees during training and outputs a mode of classes for classification or the average prediction for regression of the individual trees. It is used in the project due to its ability to handle high dimensional data with numerous features, handling missing values, and reduce overfitting. The next algorithm is gradient boosting. It is an ensemble learning method that builds a strong predictive model by combining multiple weak models in a stage-wise manner. It builds trees sequentially with each tree correcting errors made by previous ones. Gradient boosting is used in the project for its high predictive accuracy and robustness against overfitting. The next algorithm is XGBoost. XGBoost stands for Extreme Gradient Boosting, which is an optimized implementation of gradient boosting. It is known for its scalability, speed, and accuracy. XGBoost is used in the project for its ability to handle large data sets efficiently and deliver high performance in terms of predictive accuracy. The next algorithm is KNN, which is K nearest neighbors. KNN is simple and effective non-parametric classification algorithm. It assigns a class label to an instance based on majority class among its K nearest neighbors in the feature space. KNN is used in the project for its simplicity and ability to capture local patterns in the data. The next algorithm is voting classifier. Voting classifier is an ensemble learning technique that combines multiple individual classifiers and aggregates their predictions to make a final prediction. It can use different algorithms or the same algorithm with different hyperparameters. Voting classifier is used in the project to leverage the strengths of multiple algorithms and improve overall predictive performance. Coming to the next algorithm, which is AdaBoost, which is also called as adaptive boosting. It is an ensemble learning method that combines multiple weak classifiers to create a strong classifier. It focuses on instances that are hard to classify and adjusts the weights in incorrectly classified instances to improve performance. AdaBoost is used in the project for its ability to handle complex data sets and improve generalization. The next algorithm is bagging classifier, which is bootstrap aggregating technique. Bagging is an ensemble learning technique that creates multiple subsets of the training data by bootstrapping and trains a base learner on each subset. The final prediction is made by averaging or voting over the predictions of all base learners. Bagging classifier is used in the project for its ability to reduce variance and improve stability. The next algorithm is support vector machine. SVM is a supervised learning algorithm that separates data points into different classes by finding the hyperplane that maximizes the margin between classes. It is used in the project for its effectiveness in handling high dimensional data and ability to find complex decision boundaries. The next algorithm is decision tree. Decision tree is a tree-like structure where internal nodes represent features, branches represent decisions, and leaf nodes represent class labels. It is used in the project for its simplicity, interpretability, and ability to handle both numerical and categorical data. The last algorithm is logistic regression. Logistic regression is a statistical method used for binary classification. It models the probability that an instance belongs to a particular class using the logistic function. Logistic function. Logistic regression is used in the project for its simplicity, interpretability, and efficiency in handling large data sets. We have used performance metrics, which are accuracy, precision, recall, and FN score to evaluate all the models built in the project. So here we have performance comparison graphs for all those metrics. This is accuracy comparison graph. Here in the accuracy comparison graph, x-axis represents algorithm names and y-axis represents accuracy score for each algorithm. Similarly, we will have for precision, recall, and FN score graphs also. Coming to the accuracy, it is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. This is precision score comparison graph. Precision is the ratio of true positive predictions to the total positive predictions, representing model's ability to correctly identify all relevant instances while minimizing false positives. This is recall comparison graph. Recall is also known as sensitivity or true positive rate. It is the ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances without missing any. This is F1 score comparison graph. F1 score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced datasets. The algorithm which performs well among all these metrics will be used for final prediction and deployment in the front end. As random forest is performing well among all the metrics, so it is used for final prediction and deploying in the front end. To execute the project, first we have to open the code folder which contains source code files. This is the code folder of the project. This is a static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in HTML templates. This is the dataset which we have used for training the algorithms. And this is the model file which contains the algorithm information and that will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is the signup.db file. This file is a database file used to store the user information. Now we have to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we have to open Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, current directory will change to the code folder's path. So here we can see that current directory is changed to the code folder's path. Now we need to compile the app.py file using the command python space app.py and now click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. After running app.py file, Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. This is the localhost and this is the port. Now we have to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. As I prefer Google Chrome, so I'm opening it. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this is built using the Flask framework. So to execute the project, first we need to sign up if we are the new users and enter all the information related to us. As I have already registered and I have an account in it, so I'll directly sign in. So click on sign in. Here we need to provide our username and the password to sign in. Click on login. I have logged in successfully and I'm redirected to prediction page. So here we can see the parameters which are need to be entered. Based on the given parameters, we will get the prediction. And these are the drug related parameters. Before entering the parameters, we will understand them. So here the first parameter is the age of the person. The next one is gender of the person. Coming to heroin, it is highly addictive opioid drug synthesized from morphine, causing euphoria and sedation upon consumption. Coming to cocaine, it is a powerful stimulant drug derived from coca plant known for euphoric effects and potential for addiction and harmful health consequences. The next one is phenytoin analog. These are synthetic opioids similar to phenytoin, a potent pain reliever but with slight chemical modifications. They are often illegally manufactured and can be highly potent and dangerous. Coming to oxycodone. Oxycodone is a prescription opioid medication used for pain relief, but it is also commonly abused drug due to its euphoric effects. The next one is oxymorphone. It is a semi-synthetic opioid medication used for pain management, similar to oxycodone but more potent. Coming to ethanol. Ethanol is commonly known as alcohol and it is central nervous system depressant and psychoactive substance found in alcoholic beverages. The next one is hydrocodone. It is a prescription opioid medication used for pain relief, often combined with acetaminophen and ibuprofen. The next one is benzodiazepine. These are the class of psychoactive drugs used to treat anxiety, insomnia, and other conditions known for their sedative and calming effects. The next one is methadone. It is synthetic opioid medication used for pain management and as a medication assisted treatment for opioid addiction. The next one is amphet. Amphetamines are stimulant drugs that increase activity in the central nervous system, commonly used to treat attention deficit, hyperactivity disorder, and narcolepsy, but also abused for their euphoric effects. The next one is Tramat. It is a prescription opioid medication used for moderate to severe pain relief, with effects similar to other opioids but considered to have a lower risk of dependence. The last one is hydromorphone. It is a potent opioid medication used for pain management, often prescribed in cases of severe pain or for patients who don't respond to other pain medications. As we have understood all the parameters of the drugs, so the age of the person is 48 years old and the gender is male. He does not consume heroin, so I'm giving it as no. He consumes cocaine, so I'm giving it as yes. He also consumes phenytoin analog, so I'm giving it as yes. And all the rest drugs he doesn't consume, so I'm giving all of them as no. As I have entered all the parameters, now click on submit. So here we got the prediction that there is a chance of drug overdose, which means that the person may get overdose with the drugs. Now we will try giving the other person details. So click on try again. So here, age of the person is 49 years and the gender is female. She does not consume heroin, so I'm giving it as no. She consumes cocaine, so I'm giving it as yes. She doesn't consume phenytoin analog, so I'm giving it as no. Similarly, I will enter all of the drug details. So here I have entered all the drug details, whether she will consume or not. Now click on submit. Based on the given input, here is a prediction that there is a chance of drug overdose, which means that she may get drug overdosed. Now we will try giving the other parameters. So click on try again. Here we will enter other person's details. So here I have entered all the drug related details, whether a person consumes drug or not. So now click on submit. Based on the given information, here we can see that the person is safe. Now we will enter other person's details. So click on try again. So here I have entered all the details of the person, whether he consumes drug or not. Now click on submit. Based on the information provided, here it has predicted that the person is safe. Now click on log out. In this way, just by telling whether the person takes the drug or not, here we will get the prediction that if the person is overdosed or not. So, the conclusion of the project is the project has been successfully developed, achieving its objective of creating a machine learning based system for drug overdose detection. Through thorough data analysis, model development, and implementation, the project has demonstrated its capability to predict the likelihood of drug overdose events. Among the various machine learning algorithms evaluated, Random Forest emerged as a top performer in terms of predictive accuracy and robustness. Its ability to handle high dimensional data, reduce overfitting, and capture complex patterns made the algorithm of choice for deployment in the project. Random Forest algorithm is deployed in the front end of the project. Its superior performance in predicting drug overdose events makes it the ideal choice for providing actionable insights to users through the web interface. Future enhancements involve incorporating more data sources and features, exploring advanced deep learning model, deploying the system in real-world settings for collaboration with healthcare institutions and authorities, and ensuring continuous model monitoring and updating the address evolving drug trends.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.